Well, welcome everyone. My name is Cynthia Pascal. I'm Associate Dean of the School of Engineering, and I am delighted to see you here today. Dean Fauché and I are honored to present today the John R. and Donna S. Hall Lecture. This lecture series was founded in 2002 as a way to make sure that our engineering community had the opportunity to hear from renowned engineers and scientists from academia, industry, government agencies, and to learn about topics of interest. The series was funded by an endowment founded by James Gray, who himself has a lot invested in Senseable Cities, in that he is mayor of the city of Lexington, Kentucky. John Hall was a 1955 graduate of the School of Engineering here at Vanderbilt, graduated magna cum laude, and was an All-American athlete. He's a retired chairman and Chief Executive Officer of Ashland, Inc. He served on the Vanderbilt University Board of Trust for many years and was its chair. He and his wife, Donna, are proud supporters of Vanderbilt. And as a side note, John's brother, James Hall, was past chairman of the National Transportation Safety Board, so I'm sure he also would have had an interest in this. Our speaker today comes to us electronically. Life happens, and sometimes your flights don't work out. So we are grateful to welcome Professor Ratti via Skype. And just want to tell you a little bit about him. He graduated from Politecnico di Torino and the École Nationale des Ponts et Chaussées in Paris, and later earned his MPhil and PhD at the University of Cambridge. And his degrees are in engineering and architecture. He is a professor at the Massachusetts Institute of Technology and directs the Senseable City Lab. He is the founding partner of the International Design Office, Carlo Ratti Associati. He has authored or co-authored over 500 publications and holds several patents. His work has been exhibited worldwide. Two of his projects, the Digital Water Pavilion and the Copenhagen Wheel, have been included by Time magazine in the list of Best Inventions of the Year. He himself has been featured in Esquire magazine's Best and Brightest list and in Wired magazine's Smartest list, or Smart list. Blueprint magazine included him among the 25 people who will change the world of design. And Fast Company named him as one of the 50 most influential designers in America. And excuse me now while we switch on over. Carlo, if you want to go ahead and bring up your video and audio.
Yeah, yeah. Can you see me? Well, first of all, I'm very sorry. I spent the whole day. I was in New York. I went to the airport this morning around 9 a.m. and I spent the whole day in the airport. My flight kept on being delayed, and so in the end, we decided I was, in touch with some of you, and we decided it was better to connect via Skype because otherwise it would have been too late for the presentation. So very, very sorry. I really wanted to be with you in person. But it didn't work out. In any case, let me share my screen, and let me know when you see my screen. And so let's try to do the best we can via Skype, and I'll present, put on the table some of the things I had prepared, and then hopefully we can have a bit of conversation and Q&A and discussion. Is all okay? Just one thing, I have a little bit of echo, so maybe it's better to mute on your side just for the time while I'm presenting, and then I'll mute it later. Because usually when there's a bit of echo, then the line also is not that great. But first of all, I wanted to tell you a little bit about the work we're doing focusing on cities. And just 4 numbers about cities, 250, 75, and 80. Cities are only 2% of the crust of the planet, but they're 50%, actually a little bit over 50% of the population. There are 75% of energy consumption, and 80% of CO2 emissions. So if you can do something in order to make our cities more sustainable, then that can have a big impact at the global scale. And, what can we do with cities today? Well, there's something interesting happening at the urban scale, which is the convergence between digital and physical. And if you think about the 1990s, at the time, people thought that our lives thanks to the internet and so on, would become increasingly virtual. So much so that several people thought the cities themselves would disappear. This is Gilder, an American writer. In 1995, that's the same year when Nicholas Negroponte wrote Being Digital, so at the beginning of the booming digital revolution. He said, we're headed for the death of cities. Cities are leftover baggage from the industrial era. Well, what does this tell you? The first thing it tells you is never make prediction about the future, because no prediction could have been more wrong than this one. We know the cities have been thriving. This is a picture from Tianjin in China. China this century might actually build more urban fabric than all of humanity ever built. We know that since 2008, as we were saying, half of the world's population lives in cities, and by 2030, actually this number might swell to 5 billion. So what has happened really is that digital hasn't killed physical space like Gilder was and many other people were thinking, but actually digital and physical are recombining. If you want, you could say that the worlds of bits and atoms are coming together with us in the middle. Or another way to say it is the fact that the internet is becoming Internet of Things, is entering physical space, and is helping us to understand, describe, design, and live in cities in a different way. And that's really what we are passionate about. And we're doing this both at MIT, at the Senseable City Lab, both in Boston, in Cambridge, Massachusetts, and also in Singapore, where we have a small lab connected, a small MIT lab. Also with our design office, Carlo Ratti Associati, we're in New York, in Europe, doing a lot of work in Singapore right now. And also with some of the startups that are coming out of both of them. So we got a few over the past 2-3 years that were spun off out of the lab and out of the office. So the way I had structured the presentation today was around some questions. These are kind of the questions that many mayors today around the world are asking. The first is, how is mobility going to change? How are places for living and working going to change? What about retail? We know what's happening with Amazon, with e-commerce and so on. Is that going to destroy the very fabric, retail fabric of our cities? And finally, what about what type of urban experiences are we going to create or can we create today? So I wanted to start with mobility, and I wanted to start with this little video. That's a project we did a few years ago. That's a project that was done by Pedro Cruz from our lab at MIT. This was in MoMA, the Museum of Modern Art in New York, and it shows the city of Lisbon mapped using billions of data points collected from the taxi network. And if you look at this, that's a way to see a city in the way we couldn't do just a few years ago, but we can today. So to look in real time at all this information coming from the city and showing how the city, kind of the metabolism of the city. If you take the same type of data and you start analyzing, you can do interesting things. So this is, for instance, the same type of data we saw before. In this case, it's taxis in New York. Every little dot is a taxi pickup or a taxi drop-off. What you see here is JFK Airport. If you zoom out, JFK was down there on the slide. And then you see Manhattan and all of the boroughs. And then you can ask yourself, well, between any 2 points in Manhattan, you got hundreds of thousands of trips connecting them in the course of the year. So how many of those trips could be shared? And we know that today we like to share many things. We like to share apartments on Airbnb, couches, on couch surfing platforms. So how many of those trips could be shared? Now, if you look at this question, you cannot solve it with traditional mathematics. Traditional mathematics in this case fails simply because the amount of data is too large. So what we did here, we worked with colleagues in the mathematics department at Cornell University and also at MIT. And we used something that we call shareability networks in order to look at how many trips could be shared in New York. And what you see here on the slide is kind of a graphic representation of these shareability networks. If you're interested in knowing more, the paper is freely accessible online. And what we discovered is quite interesting, that in New York, you could actually take everybody to destination when they need to be there, but if people were ready to share mobility, you could cut the fleets by around 40%. Now, two interesting things happen out of this work. I mean, this work is ongoing, so we're still working on this, but the first results came out a few years ago. And they came to the attention of Uber. And at the time, Uber Pool didn't exist yet. Uber reached out. We started a research collaboration. And as you might know, Uber Pool does exactly this. Allows two people going more or less in the same direction to share a ride. Now, the other interesting thing that happened was that when the paper was published, it was reviewed in the New York Times. And the New York Times, wrote an article saying, well, this is interesting research, but in New York, no New Yorker would want to share anything else with any other New Yorker, let alone a car. Well, it turns out that that's not the case. It turns out that now that we're working with a lot of data together with Uber, Uber Pool has been a huge success. And in San Francisco, in New York, well, in San Francisco, over 50% of all trips every day happen by Uber Pool. And the same is happening in many cities around the world. Now, what we're doing now, actually, we are working still a lot on shareability, on sharing mobility. We're quite passionate about shareability because it means that, if you've got two people sharing a ride, it means you're removing one car from the road, which means less congestion, less energy consumption, less pollution, and overall a more livable city. So we're now working on different cities around the world. As you see here, it's a recent paper here from a few months ago looking at what we call global shareability networks, shareability patterns. And so we find a generalizable law that tells us, how many trips could be shared in different cities. Now, this is about what usually we would call ride sharing. There's another interesting thing, which is about vehicle sharing or car sharing. And we can do more and more of that because the car itself is changing, is being transformed. What you see on this slide, for instance, is some research we're doing using all of the sensors inside a car. This in particular is a Volkswagen car, and on an average Volkswagen car, you've got 2,000 or 3,000 sensors collecting information about everything inside the vehicle, in the city, things about the driver. They collect every type of information, they record everything that's happening inside the car. So, if you're moving, if you're opening the window, if you're measuring outside temperature, sometimes they're recording all the camera information from the car, and so on and so forth. So you could say today that the car is becoming like a walking sensor or a computer on wheels. And then if you add two additional sensors, like two little ears that you see over there, a little bit like the human eye, those two sensors called LiDAR, they make a three-dimensional scan of the city, like what you see here. And if you feed all of this into an AI system, then the car drives itself. And again, that's not the distant future, that's the present. Actually, together with the city of Singapore, we are working together with the city of Singapore to do the largest deployment of self-driving cars ever made right now. So there's a lot of experimentation in the city. And when this happens, when you go self-driving cars, everything changes again. And the reason is that today the car is a very inefficient piece of infrastructure. It's the car is something you use on average 5% of the time. In 95% of the time, not only it's not used, but actually it uses valuable space in our cities. But if you've got a self-driving car, then the car can give you a lift in the morning when you go to your office, and then can give a lift to somebody else in your family or to anybody else in the city. So what you're doing effectively is create a hybrid system in between public and private transportation. Now, this is, as I say, this is kind of the present. There's different levels of autonomy. The highest level is autonomy level 5, when really the car can do anything on its own. We're not there yet, but we're getting quite close. And many levels, and partially autonomous cars are already off the shelf. But when everything will be autonomous a few years from now, then other things might change in the city. For instance, this. And we all know this, that's a well-known traffic light. But actually, traffic lights appear on our roads when cars appeared on our roads, around a little over 100 years ago. But then if you've got an intelligent system where every car knows where it is and where all the other cars are, then you don't need to stop at an intersection anymore. You can keep on going, just avoiding collisions, like this. Don't try it yet. I showed this picture, this video in Naples, and And people told me, so what is new here? Now, I can make these jokes as an Italian, but I actually have corroborating evidence about this. And it's a former Italian minister who said that in Milan, traffic lights are instructions. In Rome, there are suggestions. In Naples, there are Christmas decorations. Now, if you look at this, and if you look at the intersection seems quite simple. But again, if you start to model it mathematically, it can become easily quite complex. And what you see here, for instance, is the network with all the possible trajectories at the intersection. And for every trajectory, you've got different frequencies of arrival. And so again, if you study, you find interesting things. That's a piece of research we are doing right now. It's in Singapore. It's a real intersection in Singapore. What you see is the same number of cars getting to the intersection to the left and to the right. The same kind of frequencies of arrival, but to the left, this is managed using the most sophisticated traffic light system we have today. And to the right is actually managed using a slot-based system similar to what you have in airports. And look at the difference in terms of number of cars waiting and delay per car to the left and to the right. Now, the other interesting thing is that usually the intersection is kind of the bottleneck in the city. The intersection is where you've got two competing flows fighting for the same real estate, the real estate of the middle of the intersection. And so if you can actually fix the intersection issue, then, you know, the benefits can trickle down across the whole city network. Now, just a couple of examples. So this is some of the research we're doing at our lab at MIT. I want to share with you, you know, a few examples of how we are turning this into design. And that, for instance, is a building. It's a building we just broke ground last week in Singapore. It's around a 300-meter high tower in Singapore. We designed it together with BIG. There's a few things I could tell you about the tower. It's a tower that has kind of a tropical forest at the middle. You see it there, so it becomes like a place where people can go and work in the middle of green spaces and overlook all of the city of Singapore. But beyond that, the thing is that we started thinking about parking in the tower. You know, we're building the tower today. The tower is being built today. And will be finished, say, in a couple of years. So we still need to have a lot of parking because of today's conditions. But, you know, this tower, or most other pieces of urban infrastructure, they will last for 50, 100, even 200 years. And at the same time, the life, you know, the software of the city will change a lot. For instance, mobility, as we were saying before. And so what we managed to do here is you know, we'll talk to the city. The city wanted to put a lot of parking and to put it underground. We said, well, why don't we do a couple of things? The first thing, we keep it actually above ground, but then we do the parking in a slightly different way. So we do the distance, the floor to ceiling height a bit higher, and then, you know, we move the ramps outside, and then we do the structure in a way that, you know, all these holes can be opened and closed over time, so that we can create a transformable parking space. And so today we'll use it as parking space, but in 5 or 10 years from now, if you need less space, then this can be transformed into other things, into shops, into an extension to of the offices, and so on and so forth. So really the idea that one of the important things is that technologies we are developing today, we don't know exactly how they will you know, play out in the city. And then so the infrastructure we build today, the buildings we do, the rest of the urban infrastructure is very important. We try to future-proof it and to make it compatible with you know, different future conditions that might happen in our cities. Just a few other things about mobility. This is a recent project we're doing in the city of Amsterdam. Amsterdam is a beautiful city. What you see here is the center of Amsterdam. And if you look at the center of Amsterdam, you see there's, yes, quite a few roads, but they're quite small, but there's a lot of canals. You know, Amsterdam was built really around water. So a little over a year ago, we started working with the city of Amsterdam. And again, the city of Amsterdam was very interested in mobility. So we said, well, what could we do in terms of research? And we said, well, what about self-driving boats? And we call them robots. So what could you do with a robot? You could actually use it for moving things around, like this. It's a DHL boat in Amsterdam, moving people around. You could use them in order to sense the water quality, the air quality, in order to scan and sense the urban environment. But the most interesting thing is that you can also use these as kind of floating pixels. So you can imagine almost like a floating, living, responsive architecture that can be deployed at will. Think about, creating a bridge when you need it. Think about a floating stage. Think about something you could do in case of emergency. So it becomes some kind of using the water as a platform for a flexible architecture. And of course, that's nothing new. It's something that many cities have been playing with. That's the beautiful city of Venice, where you see all the gondolas coming together during a very special event. It's called the Festa del Redentore. And you see all the gondolas coming together in order to create a temporary bridge. I think that's something I think it's quite important that, often new technologies are not about creating new needs in cities. But it's really about sometimes, going back to things we've always done, or we've always wanted to do, and, make them possible in a new way. Now, I'll tell you a little bit about some of the work we've been doing over the past 12 months. We've got a very good team, a team of course, designers, architects, and planners, but also a lot of people from computer science, artificial intelligence, to develop all of the technology behind the self-driving boats, and also people with backgrounds in the social sciences, all working together. And the first thing we try to do is think about drones. And the great success of drones is that they have only 4 engines, and you can control them very easily. So we say, can we do a boat that does a little bit the same? So we try to put 4 engines like this, 4 propellers like this, orthogonal, or 4 propellers of this kind. They're water jets. And then this is the first model, scale model, is around 1 to 4, smaller than the final one. And you can see here some of the first tests on the canals in Amsterdam. You see how easy to control it is. It's also symmetrical. So you can move it one side or the other side. Here you see another test. It can also move laterally. In the worst case, we'll open a toy company, because everybody seems to have so much fun playing with these things on the canals. And the final thing I want to share with you is about some of the discussion that's happening today about mobility in cities, and in particular about drones. If you look at this, some people think that this could be the solution for mobility in cities. Well, I don't think that's the case. I think drones such as this one could be very useful in outdoors, in places where there's not much infrastructure. In the countryside, could be very useful in, for instance, in Africa, where you lack a lot of the road infrastructure, and then this can move very easily and quickly, even if there's without too much investment. But you think about cities and densities, I don't think that's going to work just because of physics, pure physics. Physics means that in order to keep a lot of weight up in the air, then you need a lot of energy, first of all, and then you need to move a lot of air downwards, and you generate a lot of noise. And even if you maybe tomorrow will be able to reduce the noise, to use some noise cancelling, still, from a physics point of view, the amount of air you need to move, that's always going to be it's always going to be there. And that is going to produce a lot of disturbance underneath. And just to give you an example, as I mentioned, I was in New York this morning. In New York, in Lower Manhattan, there's a helipad, and you got a few tens of flights every hour taking off from there. And even with tens of flights per hour, everybody complains because of the disturbance of helicopters. Drones would be exactly the same. But if you wanted to have an impact on traffic and mobility in Manhattan, you don't need tens of flights per hour. You need tens of thousands of flights every hour. And so that will never, I think it will never be feasible in densities. But as I say, we can use them outside of cities where there's low density, where we lack some of the infrastructure. We can also use drones, much lighter drones, for sensing, for instance, air quality, for sensing other variables in the city. We can also use them for fun. That's a project we're working on at the moment. It's about using drones for doing urban graffiti. So they spray paint on walls, and people actually can control them with a collaborative interface that's going to go live in 2.5 months. And or we can use them for something else. And I'll show you now a video from the MIT campus. I need to tell you, the MIT campus, it's a great campus, but it's very difficult to navigate. And one of the reasons that every building has a number attached to it. And so when you need to go and see somebody, they might tell you, go to building 32-235. And a lot of people get lost on the way. So we did this project with drones in order to address this issue, and in particular, to help Harvard students.
Welcome to MIT. Where would you like to go? Follow me, please. The Computer Science and Artificial Intelligence Lab is the largest research lab at MIT.
To your right, the Media Lab.
To your left, the Data Center. Follow me, please. Approaching your destination. You have arrived. Welcome to Senseable City Lab. Goodbye.
All right. Well, this was just to share with you some of the changes in the work we're doing on mobility. Now, going to the second question is about, really about how is another very important component of cities. That's all of the urban fabric we have related to office spaces and the places we work. How is that going to change? And what you see here is, for instance, just a recent op-ed I did in the Harvard Business Review. And the title they gave is, "If work is digital, why do we still go to the office?" And I believe there's still a reason to go to the office, but it's probably not the same reason that was valid 10 or 15 years ago. And in order to look at this, it might be good to go back and look at the key principles of city planning and the key components of cities. And that's Le Corbusier, one of the most celebrated architects of the past century. In the 1930s, together with a group called SIAM, theorized a lot about the city, including the so-called Athens Charter, the Charte d'Athènes. And their idea was that everything should be divided in a city. In a good city, so the 4 keys to urban planning are the 4 functions of the city: dwelling, work, recreation, and transportation. But if you think about a city such as this one, which is what you see here to the left, it's a city where you separate everything, but then it means you are creating a lot of redundancy. You're basically multiplying the urban the square meters, and you got a place, a neighborhood for working, for instance, that is fully populated during the day, but is empty during the night. You got a place for instance, for sleeping, for living, which is used at night, but then totally empty during the day. And then you create a lot of traffic between the different functions. Incidentally, if that's how some cities were planned. If you go to Brasilia, for instance, was planned according to many of these principles, and that's one of the most one of the reasons why Brasilia is still struggling to cope with. Brasilia is still struggling as a city. because of this complete separation between the different functions. So it's no surprise that from the 1950s and 60s, many people, including in this country, Jane Jacobs, started saying, you know, that the most important thing in a city is looking at mixed use, is thinking about a neighborhood where you've got a bit of everything, and you juxtapose different functions. But we believe that today things are changing again. And thanks to the increased flexibility we have, actually we can use the same, we can put different functions over the same space. You know, use time is a way to overlay different functions on the city. And something could actually change the transition between public and private space and the very structure of the buildings we inhabit. And in order to look at this in more detail, I want to take you again through a tour of the MIT campus. So what you see is Boston. It's Boston downtown to the right. I'm sorry, you know, Boston is a very green city, but this is a winter picture, so that's why it looks a little bit like post-nuke. And then you got MIT, like a small city inside the city. You got Harvard up there. And MIT was one of the first campuses to be totally covered by Wi-Fi in the early 2000s. The MIT campus has always been a little bit like a living lab to test new technologies. And after it was totally covered by Wi-Fi, blanketed in the early 2000s, we started seeing big changes in the way people used to work and the way people work today. Now, it took several years, so this change is still happening. But you see, to the left, you see how people used to work, and to the right, you see, you know, how people tend to work today. Now, these two pictures are a bit extreme. To the left is the most depressing computer room I could find, no daylight and so on. And then to the right, you see a beautiful sunny day. I need to tell you it's snowing today, so it's a different story. But you know, it gives you the sense of the changes. And those are the changes we are witnessing now all over the world. You know, people used to work like this. Incidentally, that's a picture from Jacques Tati's movie Playtime, making fun of, you know, modern living. And, you know, today we tend to work more like this, like we work. So then our idea was, well, if all these changes are being generated by technology, what about going and looking at technology in detail in order to quantify them, to better understand what is going on, to collect big data about you know, the changes that are going on? And what we did then, we took all the MIT network and we started monitoring Wi-Fi activity on the MIT network, from which you can actually look at how many people are connected to every access point. And because access points are very, very dense, so you have almost like one access point every room, you really know how every space is used on the MIT campus. And for instance, what you see here, you see, you know, in the course of the day, how the bubbles you see here tell you how many people you have. And you see, you know, for instance, people waking up next to the dorms and they move into the center of the campus and so on and so forth. So how activity changes over the course of the day. Now, if you take all activity and if you aggregate it, you can look at the curve there at the top, all campus activity, that shows you something you could call the heartbeat of MIT. You'll see there is Monday morning, where people get into MIT around 9 a.m. Then a few people leave at 5 p.m. Most people keep working till late at night, so 9, 10, 11 p.m. Even in the middle of the night, you've got a lot of activity. And the same thing happens on Monday, Tuesday, Wednesday, and Thursday. Not on Friday, where, like all over the world, activity slips away quickly in the afternoon. And then Saturday and Sunday are almost like two normal days. And you know, you move the 9 to 5 people, but the baseline is very similar to the other days. It's going to be quite interesting that every Sunday night, if you look at that, you got a little dent there. You know, the dent is between 9 and 10 p.m. And that's actually when people realize, when we realize, you know, oh my God, tomorrow is Monday again. And you remember all the things you haven't finished before the beginning of the new week. So anyway, this is the overall signature of the MIT campus, but if you look at this, you can go and look at the signature of every space, how every space is being used in the course of the day. It's kind of occupancy measurements for every space, for every room, and tomorrow you could imagine almost for every square foot. And then this data, that's again interesting big data, tells you a lot of things. You can actually start analyzing, looking at frequencies, looking at clusters. And if you look at clusters, it's interesting because you get this type of map. Now, I'm pretty sure that if we had done the same thing a few years ago, this map would be very different. It would be a map where every space would have a different color, a very precise color, and all the different colors would be very clearly separated between them. And then what you see here is a bit what I was showing you before, the fact that actually different activities are starting to overlap on the same space, and those kind of functional separation are starting to blur and morph into something else. Now, if you look at this, that's about interaction of people in physical space. But then today we can measure other things as well. And what I'm showing you now is actually ongoing work. But basically, you can measure not only how people interact in physical space, but also productivity. And what you see here is papers and patents produced in different buildings at MIT, the community that produced them, and also digital connections between people. If you want, I think there's still ongoing work, but I believe there's a lot that we can learn in terms of research in architecture, and a lot of learnings about how we can design better spaces, because that's really the key principle of every organization, of a great university or any other institution or company. It's really about how you bring together people in physical space, how you allow them to exchange information in digital space as well, and what ultimately, how can you make sure that through that interaction, digital and physical, we can achieve something together. We can together achieve more than what we could do individually. So make sure that the sum is more than, that the total is more than the sum of the individual parts. So again, very excited about some of the things we're doing, and we're using some of the initial results also in some of the designs that our office is doing. These are some of the largest co-working spaces in Southern Europe. That's another one where we are using actually the outdoor spaces as a space of interaction. So the key question really is interaction between people. Or in this case, for instance, is about when you got occupancy, where people are, is about also finding a way that the building responds dynamically. So in this case, for instance, you got your preferences in terms of climate. This kind of climate bubble follows you through the building in the same way as the building knows if a space is heavily occupied or not, and adjust accordingly. So, for instance, if there's nobody in the floor goes on standby, pretty much like your computer. And if there's just a few people, then heating, cooling, and lighting will adjust to occupy. So it becomes also a way to save energy in the building and to make it more sustainable. So we're taking some of the learnings from the MIT campus and applying them to this. Oh, sorry. What happened? Sorry. Apologies about that. So the next point I want to share with you is then also what about retail? And retail as well is changing a lot. This is one of many reports, they look at what's going on in the United States. According to this one, for instance, by Credit Suisse, up to 25% of U.S. shopping malls may close in the next 5 years. That's a huge amount of real estate across all of the United States. We also know that, Amazon acquired Whole Foods just a few months ago, last year. And, if you'd asked me last year, I would have said, well, I think I will always go and shop at Whole Foods or, in similar places. But then, as you all know, Instacart, one starts using Instacart, and then, you realize after that instead of, going shopping a few times per week, then, most of the times you use Instacart, and just 10% of the times you were going to the supermarket, then you go out really to shop. So all these changes are happening, and those changes can actually have a huge impact on the cities. I was with the mayor and the vice mayor of Paris last week, and the vice mayor of Paris in charge of planning, and he was saying, he was very concerned about, what's happening with commerce. His question was, is e-commerce going to destroy all of the commerce, the retail fabric of our cities, which is what makes most of the streets great, and the places that attract people, the places, that, imagine if all of that were to shut down in large cities, what would remain? If everything were to come to our homes just through Amazon or similar. And also imagine the consequences in terms of additional traffic, because it needs much more mobility in order to shuttle around all these kind of parcels through the city. So those are kind of big questions when you look at how cities are changing, how they could be tomorrow. And I want to say also, those questions don't have a clear answer. So the way we'll end up in 5, 10, or 20 years will depend on the decisions we make today. So I think it's very important that as designers we engage with these questions, and we look at what could be the possible outcomes. Because only if we do this, if we engage with this question, then we can decide, or can put pressure on politicians in order to make decisions that will allow us to go and to build one type of city or another type of city. So I don't think there's a clear answer about what type of city we're going to build in terms of retail, but I want to share with you a few projects we've been engaging with in the past 2 or 3 years that look at retail and that experiment with different dimensions of retail and new technologies. The first one is a project we did at the World Expo at the World's Fair 2015 in Milan. The World's Fair was in 2010 in Shanghai, 2015 in Milan, 2020 will be Dubai. And over there we were fortunate enough to do 2 pavilions. And one of the 2 pavilions was what they called the Future Supermarket. And why Future Supermarket? Because the theme of the World Expo in Milan was feeding the planet. So it was about producing food, about transforming food, eating food, and of course, selling food in supermarket. So we were given a space, so we didn't design the shoebox. The shoebox was given to us, but we could do anything we wanted inside and outside. And we knew what we didn't want to do. We didn't want to do this. It's a beautiful picture by Andreas Gurski, one of the greatest photographer, a great photographer. But it's an alienating picture of the supermarket of the 20th century. Our idea, our inspiration was more like in this sentence by Mr. Palomar by Italo Calvino. And I'm sure many of you know Invisible Cities by Italo Calvino. Mr. Palomar is another book, and it's about a character called Mr. Palomar, who's a little bit provincial and a little bit aloof. And Mr. Palomar one day goes to Paris, enters a fromagerie, a cheese shop, and starts thinking about all the stories behind all the different products in the fromagerie. And little by little, the shops becomes, for him, like a museum or like the Louvre. Calvino says, the shop is a museum. Mr. Palomar, visiting it, feels as he does in the Louvre. Behind every displayed object, the presence of the civilization has given it form, it takes form from it. And so this idea that objects can tell us stories is not new. It's something many people are trying to look at. For instance, what you see here is what Tesco, it's a big supermarket chain, originally from the UK, but now active all over the world, and try to do. If you look at this carefully, you see it's a subway in Seoul. And their idea was, take a phone, you take a picture of a product, you learn about the product, and then you can buy it. If you look at this, it was probably the right question, but I'm not sure it was the right answer. Because it's quite alienating as well. It's about yourself with a screen in front of you and another screen behind it. So, and not social at all, no social interaction at all. Our idea was different, was, can we actually use technology to bring back this to life? Or better, basically, you take this as an inspiration and bring it into the supermarket. And if you look at this, which is a traditional market, you look at the richness of interaction between people and products, or people and people through products. And the way we try to do it is by, first of all, putting everything on tables. A table is a beautiful interface. As humans, we've been using tables for thousands of years to eat together, to sell things, to share things. And at the top of the table, we put a bunch of Kinect sensors that detect your body motion and do kind of a simplified three-dimensional scan of the body, so that information would follow seamlessly. So you see here one of the initial sketches, the idea that you approach an apple, and if you want, you can buy that apple in 1 second, as you do today. You got 4 seconds, you can actually learn a bit more about that apple. And if you got 15 seconds, maybe you can see the video of the orchard from where the apple is coming from. Now, we designed the whole supermarket a bit like a stage, like a theater. We like the idea that you could see all the products in one go. And, with the different layers of information, the physical, well, first of all, the physical products, and then information about it. And then at the top, aggregated information about, say, the most popular things and, what people have been touching, buying, and interacting with in the course of the past 24 hours. What you see here is the finished supermarket. It was actually very popular at the World's Fair. It was one of the most visited pavilions. It won a number of prizes. You see here the different layers of information, one about the other. You see people interacting with products. The kids loved it. They could actually run from one to the other and see this accordion of information opening up. The interesting thing as well, there's a lot of technology, but it's very seamless. It's a little bit what Mark Weiser, the great computer scientist from Xerox PARC, would have called, calm technology, technology that's in the background. It's there, but you don't see it. And so you could be like 5-year-old or a 95-year-old and still be able to interact with it in a very immediate way. And then, if you interact just for a few seconds, you learn basic things like nutritional values or carbon footprint, but the more you play with it, the more you discover about those products. And here's a little video about the experience inside. Okay. By the way, I just got a text message from Cynthia saying that actually you cannot see me anymore, and you're right, it's dark and so on. So let me shout to Siri to turn the lights on. Hey Siri, lights on. Okay, sorry. Thanks. What you see here is so maybe you see me better now. Sorry, I didn't realize that it became dark outside, and so you couldn't see me anymore. But what I want to show you here is actually this is a real world supermarket just completed. It actually uses the same technology we developed at the World's Fair, and it's interesting because the World's Fair or the Expo is always a very exciting time in order to try out new things. So for architects, for designers, it's really very exciting. Where you can try out something, you can see how people respond, and then you can take this into the real world. So that's one of the first supermarkets that took the same ideas into the real world. And then we're also working in retail with another company called EATALY. Some of you might have seen it. It has been very successful in New York, now in Boston, in Chicago. There's one in Los Angeles, opened a few months ago. And there we've been working on a few projects, including recently with this new format called EATALY World. And EATALY World is like in a bigger format where you can experience not only consumption of food, you can only buy food, but also see production of food. What we've been doing is we were asking ourselves, how could you let everybody have the experience of, say, organic farmer? Usually if you live on a farm, you plant something, and then every day you go and check out how things are growing and so on. And so we try to use digital and physical interaction in order to do that in this place. So the idea is you could actually plant your seeds, and then you grow them. Here there's actually water underneath, so they grow hydroponically, so they grow using just water and nutrients. And then you can follow this. You can follow this in different ways. First of all, when you're actually moving down the space, you see what people planted one day before, or 2 or 3 or 5 or 10 or 3 weeks before. And so basically when you're moving through the space, it's almost like moving through time, because you see things that were planted before and you see them here. And at the same time, you can also follow this on a day-by-day basis. So you can actually get real-time information about what is growing, and then when it's ready for you to harvest, or who's eating it. So again, this idea of traceability, how we can actually learn more about food and where it's coming from, and what it entails growing food. So again, the idea of doing this with both the idea of producing, but also the idea of educating and sharing information about products. Now, and the final thing I want to share with you is, we looked at mobility, we looked at the urban fabric, and in particular office spaces. We looked at retail, another big chunk of our cities. But what is this all about? I think the most exciting thing is that thanks to technology, we can create new experiences in cities. And we saw before experiences related to mobility, to offices, to retail. But it's something a bit more general. It's about our interaction with the built environment. And here I want to finish and show you just a project we did at the World's Fair before Milan. This was in Zaragoza, Spain. Here the theme was not feeding the planet, but was about water. And the mayor came to us, the mayor of the city came to us and asked us, well, what could we do to show actually how today we can control water in a different and a more precise way. And so one of the ideas that came out was, imagine you got a pipe, and on that pipe you got many tabs, opening and closing controlled by a computer. Then what you can create is like a living water wall. A water wall where you can show images or text or patterns, also something that opens up when you approach it. So the mayor liked the idea. So we got the commission to design the building at the entrance of the World's Fair. It's called Digital Water Pavilion. No doors or windows. You just approach it and it opens up. Inside also all the walls expand and shrink based on how many people you have. The roof is also covered with a thin layer of water. And if you got too much wind, you can lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears. Now, we had a lot of fun doing the video, but we didn't really think that they would build it. And then what happened is that kind of like 9 months to a year before the opening of the expo, Time magazine listed the idea, the project, as one of the best inventions of the year. So then, we had to build it very quickly. And, we made it. It's actually one of the buildings from the expo that's still being operated in the city. What you see here is this guy, I like this picture with this guy with a trolley. You see, he had a trolley, he was going to the station. But actually stopped there because he couldn't figure out what the hell was going on in the building. He actually missed the train in order to try to figure out what was going on with the water walls. It's quite interesting because the water walls, when you cut the water in certain shapes, it almost looks like the water is flowing in reverse, so from the bottom to the top. And so that's quite surprising the first time you see it. This was actually during the opening. It was digital projections on the water and actually the water itself. So you could say actually it's about pixels made of water and pixels made of light superimposed. And here it was myself trying not to get wet. So I was trying to test all of the sensors that basically detect people when they approach the building and then open up parts of the building to let you in. And I should tell you now what happened one night when all of the sensors stopped working. And that night we were terrified. We were terrified because the building would keep on doing its some crazy things like cuts and holes and images and text and patterns, but without responding to people anymore. But actually that night was one of the most fun nights ever. That night thousands of kids from all over the city went to the building to play a new game. Not anymore a building that opens up to let you in, but a building that you need to engage like this. And for us, it was an interesting lesson because, as architects, engineers, as planners, we always think that we know that, and we know how people will use the stuff we design. But reality, and especially human reality, and especially human reality when it interacts with a built environment and becomes more and more responsive, well, it's always a surprise. In this case, it was a good surprise. Thank you. By the way, I think you're still on mute, so actually I cannot hear you. But I see, actually I will now go back to full screen.
Thank you so much, Carlo.
I can see you. Yeah, no, I cannot see you. I cannot hear you.
Oh, okay. Oh, thank you. Right, we're still muted. Thank you, Carlo. Can you hear me now?
Perfect. Perfect. So was it, how was the quality of the sound and everything? Could you follow? Was it okay?
It was fine. Thank you. Yes. So I'd like to offer the opportunity for a couple of questions now. I realize it's a couple minutes after 5. In order to catch your question, we need to have you talk right into the microphone. So here and then here.
Hi, thanks for coming. I'm a student at Vanderbilt University, and recently I've been looking into urban planning masters. So I understand many schools are design-focused or policy-focused, but what are schools that are more like what MIT is doing, more like technology-focused, innovation-focused, yeah, that's...
And I need to tell you, I didn't hear super well. So the line was a bit, I didn't hear very well. Could you please repeat the end of the sentence, the end of the question?
Yeah, just what are schools with a Masters of Urban Planning that are very like innovation or design focused, sort of like what Senseable is doing?
Yeah. Well, I'll tell you briefly, and I hope I understood the question correctly, but it's, I'll tell you briefly about the disciplines we have in the lab. And, you know, when you look at this space of smart cities, I actually hate the word smart city, but you know, for us, Sensible City is a bit focusing more, not necessarily on technology, but more on the human side of things. But anyway, if you look at this space, then what you want to do is put together many different disciplines. On the one hand, you got the disciplines related to design and planning and engineering. So the disciplines that deal with the built environment. On the other side, you got disciplines that deal with technology. So in the lab, we got people coming from computer science, from artificial intelligence, from computer science. Also some, you know, when you look at studying complex systems, you also have people with backgrounds sometimes in mathematics and physics. But then, you know, you look at this convergence, and this is a convergence between the physical world and also the world of data. But then the ultimate goal for this is really to make more livable cities. And then, so then that's where you want to have people with backgrounds in the social sciences. It could be about economists, it could be sociologists, and so on and so forth. And that's very important. It's really about, you know, what is the ultimate goal of this is really to see how we can hopefully improve living experience in the city. So what we want to do is really break traditional silos, and that's what we try to do at MIT. I see this happening more and more in many other schools, but for us, one easy way to do it is really to use the project as a way to bring together people and force people to collaborate. So the way you break down silos effectively is actually by putting around the table different disciplines and saying, you know, well, we need to address this issue, this problem, we want to do this design, and that becomes the glue that focuses everybody on the same task and break down, as I was saying, some of the boundaries that tend to come from the past and tend to still otherwise to hamper collaboration.
Thank you. Enjoyed your talk. I'm a faculty member here. I am curious about how you see the Sensible Cities integrating with healthcare deliveries and telemedicine and such as that.
You know, I'm sorry, I think the line on this way is not very clear. Say, I heard, you'd like to hear how I see Sensible Cities, but then I didn't hear the second part.
How do you propose Sensible Cities integrating with healthcare delivery systems and telemedicine and those kinds of initiatives?
Sure. Well, thanks a lot. Thanks a lot for this question. Actually, I didn't show projects related to this, but we are doing quite a few things in this space. And I'll give you two answers. First of all, I'll tell you about one project that was just became a startup. And in this project is something we've been working on the past couple of years with colleagues in biological engineering. And what we started doing is actually to, well, first of all, let me say something before that, is I think many of you are familiar with the notion of the human microbiome, which is all the viruses and bacteria living inside our bodies. And, you know, most people think the human microbiome is a main determinant of health. And the reason, you know, in the past it was not very well known is that only with modern genomics, we started being able to characterize and quantify and describe the microbiome. So the idea is that a few years from now, we might be able actually to monitor the human microbiome for all of us almost on a daily basis. Today, however, that's still difficult. The reason is that you cannot do it on a chip. You cannot do lab on a chip. You need to take it to a lab, and it's quite expensive. And so what we started doing a couple of years ago is actually to monitor the microbiome of the city. And the city has a beautiful aggregator, which is sewage. So what we started doing was to go into sewage, take samples of sewage, and then start analyzing with metagenomics and metabolomics and so on in order to really understand how the signature that you find in sewage tells us something about the health of the population. And what you find is quite extraordinary. It's that, you can find very interesting things. For instance, just by looking at sewage in a certain point, and, first of all, you need to develop a little model that tells you sewage in that point, how it relates to a given population upstream. But, you can, for instance, look at the obesity rate, the diabetes rate for the population upstream. You can also look at other things, and that's, something that's the startup. It just was started a few months ago by two of the people who are working on the project, and actually just made it to Y Combinator, so they're now in San Francisco developing this. But he's looking at this to get health information and also information, for instance, about opioids, that you can find into sewage and many other things that tell you really about the health signature of a certain neighborhood. So that's one of the things we've been working on. More generally, I think there's a very big opportunity in cities, and in particular call it in sensible cities or smart cities, because I believe that, if you look at the equation behind health, it's something that combines 3 or 4 vectors. It's about, one vector is your genetic information, one vector is about the microbiome, one vector is about the environment. Do you live in a polluted place? Do you live in a quiet city, in a polluted city, and so on? And the last one, which is very important, is about yourself. It's about your activity, physical activity or not, and so on. How do you behave? Today, for the first time, I believe we are able to measure all the 4 vectors. And if we start doing this, especially the last 2 are the ones that you can easily measure in a sensible city. I didn't show it tonight. We've done a lot of work, but we've done a lot of work about air quality. Also about monitoring human movement. We have a project. You can find all of this on our website, where we looked at traces of people through the city, traces such as the one from apps that monitor when you're going running or walking and so on. So all anonymized, but you can then look at physical activity during the day. So we're starting to be able to map all of this. Now, all of this at the moment is in different databases, but if we're able to combine it and to get a large enough sample, I think we can crack many of those still open questions about health, thanks to really looking at it. It happened at the intersection of these kind of 4 vectors. Again, the genetic information, the microbiome, the quality of the environment, and how we behave in it. I hope I answered your question. I hope this was the question. So anyway, I hope this was the question.
Thank you so much, Professor Ratti. If you all will join me in thanking Professor Ratti.
But thank you very, very much. I really wanted to be with you in person, so I'm very, really unhappy that today didn't work out. But I hope to see you soon there on your beautiful campus. And if not, if any of you is in Boston or in Singapore, really do come, do stop by, and we can talk more, and do join the lab and come visit us. So really looking forward to continuing this conversation.
Thank you so much. We'd love to see you. Bye-bye.